Hi, and welcome to Tom Kennedy Science, and I'm your host, Dr. Tom Kennedy. Today, we're going to talk about the human population. How did we get to 7.8 billion people in 2021? So I want to be able to explain what caused the human population to rapidly grow in the last 200 years. Yes, I split my infinitive, and it's okay. Oh, and by the way, do I look a little different today? Yep, I'm sporting a mustache for as long as my wife will let me. We'll try to get away with it here for a bit. But that's a good question, right? Let's not why I can't have the mustache, but how did the human population get so big? How did that work? I mean, think about this. The humans, as a species, were about 200,000 years old. That's a long time. We may be 300,000 years old. And for much of that time, we had a population of in the tens of millions. And in fact, during the Ice Age, it was probably in the low millions, and that's it. So what caused this rapid population growth of the last 200 years? You're thinking about this, right? Well, humans, like any other population, you need resources. And one of the most important resources is energy. And we have a very cheap source of energy on this planet. We have fossil fuels, coal and oil. Now, it takes more than just having a cheap source of energy for rapid population growth. I mean, those coal deposits have been around for all of our existence. What changed? Well, there's a few things that happened. One is you have to have advances in technology. You have to have the technology to extract that cheap energy. You have to have the technology to transport it and move it around and exploit it. So, diesel engines. Wow, diesel engines and power plants. Incredibly important. You're probably going, diesel engine? Tom, just because you drive a diesel doesn't mean that diesel engines are the answer. Well, actually they are. Because diesel engines allowed us to easily transport coal and oil around the planet quite easily. And as we're going to talk about with the next one, it helps out with the agriculture as well. Let's just assume that humans are about 200,000 years old, potentially older. Now, at the end of the last ice age, about 10,000 years ago, we had the first wave of agricultural revolution. And this is where humans basically transitioned from hunter-gatherers to agriculture. And this, of course, led to the first cities. This led to the rise of civilization. And during the last 10,000 years, the human population went from probably the low millions into the tens of millions, but most likely under 100 million. And it slowly rose over the last 10,000 years. So what led to the agricultural revolution? Why did we spend 95% of our existence as hunter-gatherers? Well, one answer is we had a stable climate for the first time. I mean, we've been in an ice age with pretty unstable climate for much of our existence. And of course, a change in technology. We had rudimentary tools that allowed us to start growing crops. Why did we abandon that hunter-gatherer lifestyle? And you're probably going, to grow food, of course. Not so fast. The very first crops may have been sowed so that they could harvest them and brew beer. Now, I'm not kidding, I promise you. There are anthropologists out there that think that the entire agricultural revolution was caused so that people could brew beer. I mean, could you imagine some cavemen out there? They had their pot and there's some fermented grasses in there. And you know that it's a bunch of dudes. And one dude looked at another dude and said, "Hey man, I dare you to drink that." And some dude, probably some girl standing around, picked it up and drank it and goes, I feel pretty good. That's pretty good. And then we had beer and the agricultural revolution. And if you don't believe me, go Google it. You can actually find a pretty interesting article in the New York Times about how brewing and beer sparked the agricultural revolution and the rise of civilization. And in fact, in ancient times, people could use beer as currency. Pretty awesome. But that was about 10,000 years ago. And it wasn't until the 1800s when we reached our first billion people. And then since the 1800s, in the last 200 years, about 1% of our existence, we've gone from a billion to 7.8 billion people in 2021. And this was caused by a second agricultural revolution. And this is where our cheap energy source, coal and oil and advances in technology like the diesel engine, specifically an internal combustion engine, but it's really just the diesel engines that allowed us to have tractors, large ships, so we could have an enormous field. We don't need manpower anymore. We got big tractors that can sow the seeds, clear the fields, harvest our food, transport that food. We could even refrigerate that food, and we can grow food, lots of it, cheaply, and cheaply transport it around the planet. So there it is. That's it. That's the main answer. Wait, is there more to this? I know that some of you are going, wait, there's got to be more. It's medicine. You know, if I asked somebody randomly and I said, hey, why did we go from 1 billion people to 7.8 billion people in 200 years? They're going to say, changes in medicine. Actually, it's a blip. It's insignificant. What it has done is significantly increased our lifespan. Because now, because of things like vaccinations, clean water, antibiotics, your chance of surviving past the age of 5 is much higher than it was a few hundred years ago. And vaccinations have led to the eradication of many diseases that once nailed small children. And then same with, having cleaner drinking water. But if you still don't believe me, the populations that are growing the fastest occur in countries with some of the worst healthcare and have higher childhood mortality. So we know that changes in medicine didn't lead to the rapid population growth. It's what I just explained about technology and cheap energy. I know, it's pretty crazy. So why do we talk about this? Why do we care about the human population? Well, if you look at the human population, you can see that it continues to grow. We also talk about the growth rate. That's a chart on the right. And you'll notice that the growth rate is declining. It's gone from about 2% a year down to about 1% a year. That's a good thing. It needs to decline more. But the problem is, with 7.8 billion people, even if you reduce your growth rate down to 1%, you're still adding nearly 80 million people per year. So you have like this inertia. If you only had like 100 people and you have 1%, you're only adding one person a year. 1,000 people, you're adding 10. 10,000, you're adding, 100. But when you already have 7.8 billion people, 1% of that, of course, is like 78 million to 80 million people. So even though the growth rate continues to decline, the population is still expanding rapidly because of this population inertia. Why do we care about this? Why do we care so much about the size of the human population? Well, the problem is that we all are dependent on the earth for resources. We need coal and oil, right? We need that cheap source of energy. That's why it's imperative that we switch from fossil fuels to more renewable energy sources and ones that are clean so we don't impact the planet by releasing enormous amounts of carbon dioxide back into the atmosphere, which is changing our climate. So this is important. We're connected to this planet. We extract resources from it. And the earth has a carrying capacity. Every ecosystem has what is called a carrying capacity. This picture right here, what it shows is a representation of two things: the distribution of humans across the planet and the distribution of wealth. Because even though there's 1 billion people living in Africa, notice it's not nearly as bright as places in Europe or North America. That also has to do with wealth distribution. So what exactly is a carrying capacity? Basically, imagine an ecosystem, and it can only hold so many individuals in a population based on energy and resources. Now, carrying capacity might change over time, and depending on changing resources, that carrying capacity can actually go up and down. Think about a desert. During a rainy year, you got more plant growth, more insects to eat more plants, more birds to eat the insects. So your carrying capacity in a wet year might go up. You can imagine what will happen in a dry year. It goes down. So carrying capacities aren't always necessarily fixed. And the questions with humans, are we exceeding the Earth's carrying capacity? Yes, that's apple pie. I represent a pie. We all want a part of the pie. The pie represents the resources of the Earth. The more people there are, the less pie each person gets. And the problem with some of the resource extraction that we're using, like this cheap energy source, yeah, it's very important. I don't want to sit here and poo-poo on coal and oil. It helped fuel an industrial revolution, and it basically led to our modern society. But, yeah, we're starting to warm the planet. It's having an impact on us. As we continually grow, we're extracting more resources from the planet. And we're probably nearing our carrying capacity. And that's not necessarily a good thing because we can grow some more crops out there, but it continually degrades the quality of our ecosystems as we continually clear more and more land for farms. And we're actually losing farmland to desertification. They're becoming desert as we're impacting the climate. And of course, there's our quintessential polar bear on top of a small iceberg there, representing our changing world as we're warming the planet due to our resource extraction. Well, I hope by now you understand that the human population is growing rapidly and is fueled by extracting a cheap resource from our planet and the ability to use it. So the question is, what happens when we run out of coal and oil? What's going to happen to our population? That's scary stuff. That'll be a discussion for another day. Until next time, this is Tom Kennedy Science.